All right, 12.2. It says solving right triangles. It seems like we've solved right triangles before. We kind of have. But what do we use to find missing things for a right triangle? Pythagorean theorem. So technically we have solved right triangles before, but there's other things in the right triangle that you might not be able to do. So Pythagorean theorem, you just found the lengths of the what? The sides. We didn't do anything with the angles, did we? We didn't find any of the angles. Unless they told you one of the acute angles. Then we took it away from 90 to find the other one. Make sense? Okay, so, but now what we're going to do is we're actually going to learn how to solve for the other angles inside there with not knowing either one of the angles. Okay, we'll know that it's a right triangle, so we know it's a right angle. But now today we're going to learn how to find, if I know some of the sides on the right triangle, I'm going to be able to find the other two angles in the triangle. That's something that we haven't been able to do before. And it's something that you can't do unless you know trig. All right, so that's what we're going to do. But to start us off with, we're just going to learn how to use a calculator. All right, so this is just calculator work right here. So do you have your calculator out? So I'm going to write these down, and I just want you to give me an answer or write down the answer. This is calculator. This is straight calculator. There's no work to show. You just put it in a calculator and give me an answer. Okay? Shouldn't take you long. Probably about 30 seconds. So write it down. Make sure if you have a graphing calculator, I'm telling this basically for me so I remember. So make sure you change, if it doesn't already. See, mine automatically goes to radians every single time. So that means I have to change it to degrees every time, which is kind of a pain, but that's the way it goes. Now, most of you have a calculator where, what are you going to punch in first? You're going to punch in cosine or you're going to punch in 30?
Cosine.
You're going to, you sure?
Yes, sir.
On most
I
of your,
think I got the right answer.
yeah, on some of your calculators you will. On some of them, you're going to punch in what? 30 first, and then hit cosine.
What's the other?
You got to know how your calculator works because different calculators work different ways. I used to know the word for it. It's called like direct algebraic logic or something like that. I think that might be what it's called. When it's, I don't even know which one is what. But anyway, one, you put cosine first, then 30, like a graphing calculator. It's exactly what you would do. You would hit cosine, and then you would hit 30. You don't even have to close parentheses. I like to just because it looks prettier. All right, and then I hit enter, and then boom, there it is. So that's what it is. And it says to round it to 4 decimal places. So that's what? 0.866. Oops. 0.866 what? Now, a lot of people think, well, you don't really need that 0 there. But they do say 4 decimal places, okay? So you must fill in that 4th decimal place, even though it's a 0, right? Because what does that tell us? That tells us the number to the right of it is what? Less than 5. Okay, so that does tell us something right there. So that 0 is important, okay? You with me on that?
Yeah.
All right, let's do another one. Pretty easy so far, right? So now this is the tangent of 72. So on my calculator, you hit tangent, then you hit 72, and you don't need to put the thing in there. Is that what you got?
Yeah.
Make sure that you know how to use it. Who uses a calculator that you put 72 in first and then you hit tangent? Who's got a calculator that does that? You hit the number first and tangent. You're the only one that does that? Because it used to be most of the scientific calculators, almost all of them, you used to hit 72 then the tangent. All right. So it's kind of right. It will.
Yeah, mine uses.
So that's kind of surprising to me because I've been out of math for 10 years. Right. It's been 10 years since I've taught this stuff. So actually 11 years since I've taught geometry. All right, so I'm kind of out of touch with the technology now. So anyway, that's good because at least you do it the same way I do. So what is it? It's 0.07777. Right. So that's what it would be if you rounded to 4 decimal places because again, that's 8 rounds that 6 up to a 7. You're good to go, all right? And then this is just as easy. It's no different. So it's the sine of 26.2. So you can put decimals in there as well. 26.2. And then there you go. 44.15. And that stops right there, right? Because that 0 doesn't round it up. Everybody good so far? Yeah, that's easy. Let's do this. With that said, let's solve a triangle. What you're going to do, excuse me, you are going to do a thing that says solve the triangle. When it says solve the triangle, you're like, how in the world do I solve a triangle? Usually I solve for X, solve for Y, solve for A, solve for B. But solving a triangle seems kind of weird. Excuse me. Yeah, they put this is 72 degrees, and they put this is 8. Right? This is A, B, and C. Now, normally they do this. If this is angle B, what do you think they call the side that's opposite angle B? Well, what letter do they give it? A lowercase b. That's what they normally do. All right, so if this is angle C, then what do I call this side right here? Lowercase c, and this would be what? A. All right, but I don't need it because I already know it, okay? I don't need to put an A here. So what do they, when they say solve the triangle, that's what they're going to tell you to do. Solve the triangle. What are they asking you to do to solve a triangle? What does that mean? Find all the missing stuff. That's right. Find everything is missing. Now, to find the angle, let's start there since you mentioned that. Let's find the missing angle. Let's find the angle A. It's pretty easy. How do I solve for angle A?
72 plus 90.
Yeah, it's easier than that. You keep doing that, but it's easier than that. I say this all the time. You don't have to go 180 minus 90 minus 72. Because if it's a right triangle, you're always going to go 180 minus 90, right? When it's a right triangle. And so that's always 90. So these two angles right here always add up to 90, right? So really, all I have to do is just what? 90 minus 72. And that's what? 18? And that's 18 degrees. So that's this angle right there. It's 18 degrees. So that was pretty simple. Agreed? Didn't have to do any trig on that one, right? But look at the other ones. Normally, before we do trig, they give you two sides of a right triangle and then use Pythagorean theorem to find the third side, correct? But do we have a 30 and a 60?
Oh, yeah.
No. Do we have a 45 and a 45? No. So we can't use that. So we can't use those special triangles to figure out the sides. So what we're going to have to do is use some trig, all right? Now, yeah. So this is where it really comes in. Excuse me. Can't get my throat right. So, listen. So, what we're going to do is we're going to set up a little trig function is what we call it, okay? Or a little equation. You could use either one of these angles. Since I know both of these angles, you can use either one, okay? You could use the 72 or you could use the 18. In the book, they use the 72, so let's use the 72 because that's the one they originally gave us. Let's just do that, all right? What do I mean by let's use it? Well, let's do a trig function. Let's use either the sine, the cosine, or the tangent, okay? So what I'm going to have to do is this. I cannot use, look, everybody look. I don't know B and I don't know C. So B is opposite and C is hypotenuse. Agreed? So I cannot use what's opposite and hypotenuse. Which one?
So.
The sine, right. I can't use sine because I don't know the opposite and I don't know the hypotenuse. I got to know at least one of them. So I could use what? Adjacent. I know the adjacent side to this, okay? So which two trig ratios or identities or functions use adjacent? Cosine and tangent. So I could use either one. It doesn't matter, all right? But let's say I wanted to find C first. Let's say find C. Which one am I going to use? I got three to pick from. I'm going to use the cosine because it's got adjacent and it's got hypotenuse. You with me on that? All right, so watch how we set this up. So what am I using? What function am I using? Cosine. So I'm going to use the cosine of which angle, though? Which angle am I using? I'm using angle B, which is what? How many degrees? 72. So I'm going to go the cosine of 72. Now, this is just a number, isn't it? This is just a number because I could take this and put it into a calculator and get a decimal. Would you agree?
Yeah.
All right. So remember, the cosine of 72 is just a decimal number. And that's equal to what? What over what? Adjacent over hypotenuse. So what's the adjacent? What's the adjacent?
8 over C.
It's 8. The adjacent, it's not, we don't use the 72. We already used the 72. The cosine of 72 is equal to the adjacent over the hypotenuse. The adjacent is 8, and the hypotenuse is what?
C.
Now, what are we trying to solve for now?
C.
Let's solve for C. All right? Now, the algebra is maybe a little bit tricky if you haven't had algebra in a while, but I got to get C by itself. Well, C is on the bottom. Say it. Go ahead.
Multiply by C.
That's it. You got it. So what I'm going to do is multiply both sides by C. Why do I multiply it by C? So I can get it on the top. Now, if I multiply the right side by C, then I multiply the left side by C. Everybody with me?
Yep.
So these C's cancel out. Let's do this in the same step since we're running out of time. I want to get C by itself. So remember, this is just a number, isn't it? Cosine of 72. So how can I get rid of this number if it's being multiplied by C? Divide it. So I come over here and I divide it by what? The cosine of 72. There's no reason to put that into a decimal and divide it by a decimal. Just keep it cosine of 72. So I'm going to divide this by, I've already canceled out, yeah. Well, these will cancel out and I'll be left with a C. But let's do right here. So I have to also divide this side by the cosine of 72. See what I did? I did it in the same step. I did 2 steps in one, basically. All right? So now, these cancel. So C, don't leave yet. C is equal to 8. Don't leave yet. I hear you packing up. Don't leave. 8 divided by what? The cosine of 72. So how do I figure out what that's equal to? I come over to my calculator, and then I figure it out. Okay, so here we go. Let's clear everything. Because I hit H on my keyboard. All right, everybody watch. Why are we packing up? I don't understand. So it's 8. I didn't tell you to go. I don't care what time it is. I didn't tell you to go. So it's 8 divided by the cosine of 72. And then I think this turned off. I don't know if it went back to I don't know if it went back to degrees or not. Let's see. Did it? Yeah, it stayed in degrees. Good. So there it is right there. So what's my answer? 25.88. Let's round it to one decimal place.
25.9.
It's 25.9. So that's what C is equal to. All right, is 25.9. Now, if you wanted to, what's the other thing we have to find? We got to find B, don't we? I could use what? Pythagorean theorem if I wanted to, or I could use opposite over adjacent. So you could use the tangent, and I'll leave it right there. So you could go the tangent of 72 is equal to opposite over adjacent, then solve for B, and then that's what this is going to be right there. Okay? We'll finish this up tomorrow.